Pre-Algebra, Unit 1, Formative 2 Review. This part of Unit 1 covers fraction operations, decimal operations, and also estimating. Let's go to work. Remember that when you add and subtract fractions, you always have to have a common denominator. Let's look at this first example. 5 3/4 minus 1/3. You need a common denominator. I am going to keep my whole number and set my fractions up currently with denominators of 4 and 3 to have a denominator of 12 because that's my least common denominator. Then I want to look for the relationship here. To go from 4 to 12, I multiply by 3. So I'm going to multiply that numerator and get 9. So that's 5 and 9/12. Then I'm going to look at this one, and to go from 3 to 12, I multiply by 4. So that numerator becomes 4. Then I can add together. I write my whole number 5, and then I add my numerators together, which is 13 over 12. Now remember, whenever you have a larger numerator than a denominator, you need to rewrite that. So I'm just going to worry about my 13/12. I'm going to write that as 1, because 12 goes into 13 one time. There is 1 left over, and that is 1 and 1/12. But don't forget, you already started with 5. So if you put that 5 and 1 together, you get a total of 6 and 1/12. And that is in simplest form. Now let's go over and look at 4/5 plus negative 2/3. Again, when you add and subtract fractions, you need to have a common denominator. So when I am working with 5 and 3, my common denominator would be 15. Now let's go back and look at those relationships. To go from 5 to 15, I multiply by 3. So 3 times 4 gives me a numerator of 12. Over here, to go from 3 to 15, I multiply by 5. So that numerator is 10. And I'm going to be careful with my signs because it was plus negative. Well, when I add opposite signs, remember, when you put them together, they cancel each other out. So you're trying to figure out how many you have left over. If you have 12 positives and 10 negatives, they're going to cancel each other out and leave you with 2. And 12 is your bigger number, and it's positive, so your answer is going to be positive. So that would be a positive 2/15. There you have followed your fraction rules and your integer rules. Remember, when you multiply and divide fractions, you absolutely do not need a common denominator. When you multiply, you want to use the shortcut available to you, which involves canceling out numerators and denominators, or simplifying. If you look at this first fraction, negative 3/10 times 2/5, 2 and 10 can both be divided by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5. There's nothing else that can be simplified, top and bottom, so I multiply across the top and get a negative 3. And you multiply across the bottom and get 25. And there was 1 negative in the problem, so I know that my answer has to be negative. If you look at the second fraction, the division problem, you have 1 4/5 divided by 3/4. Two things to remember here. One, when you multiply and divide, you absolutely always have to change mixed numbers to improper fractions. The second thing that I want you to remember is that we don't ever divide fractions. We simply keep, change, flip, or multiply by the reciprocal. So the first thing that I want to do is change my mixed number to an improper fraction. So I have 5 times 1 is 5, plus 4 is 9/5. I'm going to go ahead and change division to multiplication because I don't have to change 3/4 to an improper fraction. So I'm going to flip that fraction upside down. That's called the reciprocal. Then I can check to see if there is anything in my numerators and denominators that I can cancel or simplify, which I can divide 9 by 3 and get 3, and 3 divided by 3, which is 1. And that's as far as I can go. Then I multiply my numerators. 3 times 4 is 12, and 5 times 1 is 5. And then you can rewrite that as a mixed number. 5 goes into 12 2 times, which brings you to a total of 10, which means that there are 2 left over, and your denominator always stays the same. Remember when you multiply and divide fractions that you don't worry much about the decimal in the beginning. So when you multiply this first problem here, I'm just going to write this as a regular multiplication problem. I'm going to multiply these numbers ignoring the decimal. So I'm going to do 8 times 5, which is 40. 8 times 1 plus 4 is 12. Then I go back and I count. There is 1, 2, 3 places with a decimal in the problem. So I have to move my decimal back 3 places. So I'm going to rewrite my answer as 0.12 because I don't need that extra 0 on the end. And I go back and check, and there is 1 negative in the problem, which makes my final answer negative. So that would be negative 12 hundredths. The second problem is division. The first number always goes under the house, as we say. And I'm just going to ignore that negative until the end. But I need to move this decimal over 1 place, which means I also have to move it over here. And I'm going to put that decimal at the top right to begin with, and then I can ignore it as I'm dividing. So 3 can't go into 0, but it can go into 6 2 times. I subtract, and I bring down my 3, and 3 goes into 1 time, and I'm done. So my decimal is 2.1, and I go back to look, and I see 1 negative sign here, so I know that my final answer is negative 2.1. When you are working with math problems that involve fractions and decimals, I would decide to stick with one format and change both numbers to match. If they are fractions that you may have memorized as decimals, go ahead and change those to decimals. So for example, 3/5 I can figure out as a decimal. If I don't have it memorized, I can go off to the side and I can say, okay, 3 divided by 5. I just add a decimal with the 0, and 5 goes into 30 6 times. So that decimal right there is 0.6. So I'm going to rewrite it as 0.6 because they are the same thing. Now, all of a sudden, I have 2 decimals, and I know how to add 2 decimals. When I add 2 decimals, I simply line up my decimals. You can add in a 0 if you want to, if that's helpful. And you're adding those. So you have 5 plus 0 is 5. 4 plus 6 is 10, and I carry the 1. And so my final, as a decimal, is 1.05. The same thing goes on my second problem. I have 6 1/4 minus 0.8 or 8/10. Again, I know 1/4 as a decimal, so I may just take the time and rewrite that as 6.25 because 1/4 is 0.25. Then I can line up my decimals and subtract. When you add and subtract, you line up your decimals. I can take 5 minus 0, which is 5, but I cannot take 8 from 2. So I'm going to come over and borrow from the 6, make my 2 a 12. 12 minus 8 is 4. 5 minus nothing is 5. And there I have both my answers in decimal form. Now, let me show you one of them. If we want to change them to fractions, let me show you this. If I wanted to do my second one, I'm going to rewrite it. If I have 6 1/4 minus 0.8, I could change that to be 6 1/4 minus 8/10. And then from there, find my common denominator, which would be 20. This would be 5/20ths. This would be 16 20ths. But you might want to stop there and notice that if you do it this way, you end up having to borrow, which is fine. It works. Let me show you the borrowing. So I would have to borrow 1 whole from my 6, so I would have 5 left. And I'm going to add in 20 to my 5, and then I could subtract, and I would get, sorry, I'm going to move that, make it a little smaller. Sorry for giving you a headache. I have 5 minus nothing, which is 5, and then 25 minus 16 is 9/20. And these two answers are actually equivalent, and I will take either. And finally, estimating. Remember, when we estimate, we want to make it short, fast, and easy. So you want to come up with numbers that you can add or subtract or multiply or divide in your head. Okay, so let's look at 13 and 1/6. 1/6 is not much of a fraction at all. It's closer to nothing than it is to the whole thing. So I'm just going to make that number 13. And then if I look at this fraction right here, 7/8 is almost the whole thing. So if I added that to 4, I would say that that's really close to 5. And I can subtract 13 minus 5 and get a total of 8. It's easy. If you look at the next one, 14.8 divided by 2.91, choose two numbers that are very easy to work with. So for 14.8, that's pretty close to 15, and I could make 2.913. Those two numbers are compatible. They're easy to divide. 15 divided by 3 is 5. Again, remember, make estimating easy.